1.1, we're going to preview what calculus is. So last year, we talked about what calculus was a little bit at the end on our calc prep after our limits. So that's kind of what we're going to be talking about before we go into limits. I need a reader. Thank you so much, Becca, for volunteering.
Calculus is the mathematics of change, velocities and accelerations. Calculus is also the mathematics of tangent lines, slopes, areas, volume, arc lengths, centroids, curvatures, and much more.
All right, so what you guys got in your summer reading, hopefully, was that you saw that calculus was the mathematics of change. All right, it is not always linear. It has some curves. It has some change going on. Now, we're going to be talking, we got through pre-calc. Congratulations, you made it. All right, and then...
Get the lightsaber, though.
We still got that. We still got the lightsaber. All right. All right. And then we're going to get into limits, and then we finally get into calculus. Now, the limit I think of as the bridge between what we did last year and what we're going to be talking about the bulk of this year. All right. Limits are kind of that bridge to it. So you saw this maybe a little bit in your summer reading. We can do some things without calculus, and some things we have to have calculus. So last year, or basically since Algebra 1, you could do slope. How do you do slope? Rise over run. Okay? But now we're going to do slope of a curve. And we talked about that last year a little bit, as we got really, really close to it. All right? Secant line curve. Okay? The slope of a secant line curve. How many points is it on a secant line? 2. And we just did algebra slope. Okay? We're going to do that a little bit more today. But really, calculus is tangent to a curve. And that's with how many? One single point. We'll talk about how to do that. And then average rate between things. And now we're going to be talking about instantaneous rate of change. This was those stupid problems back in the day that said, like, the train is leaving the station here and then arriving at the station here. How fast did that train go? And you're like, 50 miles per hour. And I say, bull crap. That train didn't go 50 miles per hour the whole time, did it? No. Because that train better started and stopped. You know? Like, it better have been not moving at the beginning and the end, true?
Yes.
Because that train didn't go 50 miles per hour. Were you jumping on that train, then you jumping off that train, did you? Did you do that? No. All right, so we're going to be talking about instantaneous rate of change. Because when you look at the speedometer, what's it doing? It's fluctuating. It's talking about the what? Instantaneous rate of change. All right, Colin last period got a speeding ticket for 86 miles per hour or something on the parkway. That is his instantaneous rate of change. All right, one that's really stupid. Don't do that. All right, height of a curve, maximum height of a curve, and then area of a rectangle, and then we're going to be talking about area under a curve today as well. So those are with and without calculus. So we saw this exact same thing last year. All right, so we're going to be talking about slopes of a secant line, and we're going to scrunch them down to what we think of as a slope of a tangent line. But really, all we're doing is we're doing algebra slope. Okay, we're doing the y2 minus y1 over x2 minus x1. Okay, that's all we're doing, but we're going to get really, really close.
Yes.
All right. All right, so this first function we're going to be looking at is x squared. All right, and I want to figure out the slopes of my secant lines going through 1.5 comma whatever 1.5 is of our function and so forth. And we're going to estimate after we find the slopes, we're going to estimate the slope of the tangent line really close to 1, 1. All right, so we have a 0.11, and we're going to find what's tangent to that 0.11. So again, we're just going to use algebra slope. So if I have to find the slope of Q1, if I'm finding the slope there, I'd do f of 1.5 minus f of 1 over 1.5 minus 1. So again, my y2 minus my y1 over x2 minus my x1. So, you guys have calculators. Let's use them. So 1.5, what is f of 1.5? 1.5 squared. 2.25 minus, what is f of 1? 1 over 1.5 minus 1. So I end up having 1.25 divided by 0.5. Basically, you double it. What do you get? 2.5. So the slope between 1, 1.
I'm thinking just what the actual slope is going to end up being.
Not yet. Don't do it yet. All right. We don't want to tell everybody. All right. And then we're going to do it with Q2. All right. So we're going to find the slope between 1, 1 and our Q2. So I'd have f of 1.1 minus f of 1 over 1.1 minus 1. So what is f of 1.1? 1.21. Minus f of 1 is still 1 over 1.1 minus 1. So we end up getting this 0.21 over 0.1, and that happens to be 2.1. So the slope of my secant line between there is 2.1. Now let's do Q3. So let's find the slope between 1, 1 and our point Q3. So I'd end up with f of 1.01 minus f of 1 over 1.01 minus 1. Well, this is a nice little pattern. What is f of 1.01? 0.01 minus f minus 1 over 1.01 minus 1. So what's my slope there? .01. Now, without even doing it, because I don't feel like it, what is the slope between 1, 1 and our point 1.001 point and f of 1.001? What is the slope there? What do we think? 2.001. All right. And then if we did it again, what do we think there? Exactly. Now, without finding out, now have we found the slope of our tangent line? Have we found our tangent slope to 1, 1 yet? No, we haven't found it. All right. However, what do we think it is? The slope of my tangent is what? 2. That's what we're going to say it is. Now, did we ever get to 2?
No.
Using this method, are we actually ever going to get to 2?
No.
No, but I'm going to say it's pretty close right now.
Yeah, we're going to get successively closer and closer and closer.
All right, I love it. All right. All right, so we talked about slopes of tangents. It's basically going to be chapters 1 through 3. All right. And then the other section that we're going to be talking about is area under a curve. We're going to be talking about that from chapters 4 through 7. All right. That's it. Those 2 big concepts all year. Like after today, we should basically take the AP exam. All right. All right. That's all we're going to do pretty much all year long. All right. So area under the curve. We talked about this a little bit last year. This one is approximating using 4 rectangles, and this one's approximating using 8 rectangles. Which one's better? The 8. Why? What's smaller? The rectangles are smaller?
There's less area.
More rectangles, more what? Shaded space it's going to cover. Love it. All right, it's going to fill in its gaps a little bit more. All right, less gaps. Is that good? All right. Could it be better than using these 8 rectangles?
Then we're going to move rectangles again.
More rectangles, right? About 20 rectangles. Would that get close?
Less gaps.
Huh? Less gaps. All right. Love it. All right. So we need to talk about some vocab before we get going. Last year we talked about left, right, and midpoint a little bit, right? Did we do midpoint? We just did left and right? All right. So we just did left and right. And that's kind of what we're going to be doing now. except we're going to be talking about what's called inscribed and circumscribed rectangles as well. So inscribed, is that under my curve or over my curve? Under. Okay? So if you see the word inscribed, this is kind of under my curve. And if you see circumscribed, what would that be? Like over the curve. Is inscribed going to be an under or over approximation? Under. All right? And then circumscribed is going to be what?
Over.
An over approximation of what the area is actually under that curve. Now, in this case, what we talked about last year is this one going from the left or the right? It's going from the left, exactly. Okay, this would be like what we called the LRAM last year. This one would be called the what? The RRAM. Now, it doesn't always happen to be that way. Both of these are increasing functions. However, if I said it's a decreasing function, guess what a left would end up doing?
Over.
That would end up going over. So is that actually an inscribed anymore? No, that would actually be a what? A circumscribed. So we need to be cautious on that. So if it's like that, an inscribed would actually need to be a what?
Why?
An RRAM. Okay? And so that's what we actually need to think about. All right. So it's about going under or over that curve. Okay, pretty good? All right.
Oh. That was pretty interesting.
Good. All right. So on this first one, we're going to find an inscribed rectangles. We're going to find the area of the curve using inscribed rectangles from 0 to 1. Okay? So how do we find the width? Do we remember? If we're going to go from 0 to 1, how do we find the width of these rectangles? B minus A over N. Okay? If you don't remember it, let's write it down. So our B is where we end up, our A is where we start, and our N is the number of rectangles that we're going to have. So what's my B? Where am I going? How far am I going?
1.
I'm going to go to 1. Minus, where am I starting? 0. Now, this one's a little tricky. How many rectangles do I have here? Somebody said it. I have 5. There's Flick, I only see 4. There's really 5 because this one doesn't really have a height. Okay? So there's actually 5 rectangles that it's being broken up into. All right? So that's how we find our width. Our B minus A over N. So my width happens to be what? 1/5. I'm actually going to use a decimal here, so I'm going to say it's 0.2. All right? All right. So is this an LRAM or an RRAM? This is an L because I'm going from the left. All right? It's inscribed because it's why? It's under. Okay? So I'm going to have a width of 0.2, and then I'm going to start out f of 0. And then I would have f of what? If I use a width of 0.2, then I would go up at 0.2. So f of 0.2. And then what would be my next one? F of what? 0.4. And then f of 0.6. And then f of 0.8. And then f of, I'm done. Why am I done now? Because there's only 5 rectangles. I already hit to going to 1. I'm between 0 and 1 now. All right? So now let's do a little bit of math. So 0.2 times, what is f of 0? I still have the function of x squared. I end up with 0. Plus, what is f of 0.2? 0.04. And then what's f of 0.4? 0.16. And then f of 0.6 is 0.36. And then f of 0.8 is 0.64. All right. So we still have our handy dandy calculator. Let's go ahead and use it. So what is 0.2 times that quantity? Point 24. Now, for our inscribed rectangles, I get an estimate of 0.24 for my area under that curve. Is that an over or under approximation? It's an under. It's definitely an under approximation. All right? Because I have gaps in between my actual. Now, let's work with circumscribed. Before we do anything, is this going to be an over or under approximation? It's an over. Now, is this an RRAM or an LRAM? This is an RRAM. Okay? It's going from the right. Now, what's my width again? It's 0.2. Okay? The way we do it again is this b minus a over n. All right, so we got 1 minus 0 over 5. So we get 0.2. And then I personally like to start from the right. So I personally would like to do f of 1. Depending on what author or teacher that you look at online or something, they might not start there, but I personally would like to go from that section. I think it makes more sense. And then plus f of what? 0.8. And then f of 0.6. And then f of, and then f of, and then f of, I'm done. All right. Why am I done? Because there's 5. I can't go past 0. Okay, I want to stay bounded between 0 and 1. So let's do a little bit of math. So I have 0.2 times, what is f of 1? 1 plus 0.64 plus, and then, all right. And then we put that into our handy dandy calculator. What is our approximate area under or over this curve? 0.44. All right, 0.44. Now, my under approximation was 0.24. My over approximation was 0.44. Well, what could we do to figure out what the possible area under the curve is? Average them. So what would we say that is? 0.34. Pretty close. All right.
Yes, it is.
Nolan, what is actually the area? 1/3.
Yes.
Okay. The actual area under the curve is 1/3. But we're going to need to know calculus to do that. All right. All right. That's all I got for you today. All right. Go on Canvas and begin.